In this video, let's discuss about the step response of a first order series RC circuit. Here I have a VIN and RNC are connected in series. Let's draw the voltage across the capacitor, voltage across the resistor, and current flowing through the circuit. Here I have given the step signal till t is equal to t. The input signal is 0 volt. Okay, at t is equal to t, the voltage suddenly input voltage rises from 0 volt to V volt. Okay, and after t is equal to t, the input voltage is staying at V volt only. That means at t is equal to till infinity, the voltage input voltage is V volt only. Okay, and before going there, let's discuss about the first capacitor basics. Capacitor acts as a short circuit if the input signal frequency is equal to infinity. The same way capacitor acts as a open circuit if the input frequency signal is 0, that means DC. Okay, in the same way, let's discuss about the from 0 to t time. So because there is no charge here, because I am considering initial charge of the capacitor Vc of 0 equal to 0 volt, that's why the Vc is equal to 0 volt and the current is 0 ampere. In the same way, the Vr is equal to 0 because there is no current flowing through the circuit. At a t is equal to infinity, because Vin is equal to acting as a DC, capacitor acts as a open circuit. If I draw at t is equal to infinity, redraw the circuit will look like this. Okay, the resistor and a capacitor, which I should replace with a open circuit. Okay, you have a V in this one. V is equal to V volt and resistor R. Because this is a open circuit, so the current flowing through the circuit will be 0 ampere. So if I measure the Vc will be V in, that means V volt. Okay, after some time, that means Vc will get charged to Vin. This is equal to V volt. In the same way, because current is equal to 0, we also know that the current flowing through the circuit is also become 0. Because the current flowing through the circuit is become 0, Vr is equal to I into R. Because the I is equal to 0, Vr is equal to 0. Okay, this is what at t is equal to infinity. At t is equal to t, you see the voltage, input voltage suddenly rising from 0 volt to V volt. That means here at this point, the input has a infinity frequency components. So because the infinity frequency components, the capacitor acts as a short circuit. If I redraw the circuit at t is equal to t, sorry, it's not infinity, at t is equal to t seconds. If I redraw the circuit, it will look like this. The resistor and the capacitor is there, and the capacitor I should replace with the short circuit, and this is the R, this is the V. The V in is equal to V volt. The current flowing through the circuit is equal to V divided by R. I is equal to V by R. The voltage across the resistor will be V in V, because there is no other component is connected. So the voltage across the resistor will be V, and the current flowing to the circuit will be V by R. Okay, because this is a first order circuit and the capacitor should reach to somehow from 0 volt to V volt, the capacitor will charge exponentially rising. Okay, like this it will go on charge. In the same way, the current flowing through the circuit will exponentially decay and finally it reaches to 0 ampere, and the voltage across the resistor will follow the current profile because V is equal to I into R. Here, at what time the capacitor will reach to V volt? Okay, generally the capacitor will take 5 tau time. Okay, here tau is equal to time constant of the circuit. Here time constant will be R equivalent into C equivalent. To find the what is the tau R equivalent into C equivalent, we need to go to the circuit here. Generally, to find the R equivalent and C equivalent, first we need to replace this sources, voltage source with a short circuit, and current source with the open circuit. Because I have only voltage source here, I should redraw with short circuit. If I redraw my circuit with short circuit, it looks like this. This is the C and this is the R, and I need to short with the short circuit the voltage source. So I need to first see what is the C equivalent. Here I have only one C, so that C equivalent will become C here. In the same way, to find the R equivalent, first I need to remove this C and look from the terminals of the C. Okay, and find what is the equivalent of the resistance. So if I remove C and look from the capacitor terminals, the R equivalent will be R only. So here my R equivalent also will become R. So the time constant tau will be RC. Now let's see what is the simulation results. I have simulated this one. Let's see how the simulation will look like. So this is how the simulation looks like. Here I am giving input voltage from 0 to 1 volt step at around 10 milliseconds. Okay, the input voltage changing from 0 volt to 1 volt. In the same way, I have used R as a 1 kilo ohms and capacitor as a 1 microfarads. If you see that at t is equal to 10 milliseconds, that voltage across the capacitor is equal to 0, that means short circuited. Eventually it went to 1 volt, which is the V in. If I see at t is equal to 10 milliseconds, the current flowing to the circuit I should be V by R, because the capacitor is short circuited. V is equal to 1 volt and R is equal to 1K, so the 1 milliampere. So if you see the current here is 1 milliampere, and eventually it reaches to 0 volt. In the same way here, if you see the voltage across the VR is equal to I into R 1K into 1 milliampere, which is equal to 1 volt. Here 1 volt, and eventually it reaches to 0 volt.